In this video, we're going to have a look at the solution to the Advent of Code Haunted Wasteland puzzle, which is day 8, and we're only going to be covering task 1. So the first thing that we need to actually do before we do anything else is read the task that we need to complete. Let's have a read of the task that we've got. So, you're still riding a camel across Desert Island when you spot a sandstorm quickly approaching. When you turn to warn the elf, she disappears before your eyes. To be fair, she's just finished warning you about ghosts a few minutes ago. One of the camel's pouches is labelled Maps. Sure enough, it's full of documents about how to navigate the desert. At least, you're pretty sure that's what they are. One of the documents contains a list of left-right instructions, and the rest of the documents seem to describe some kind of network of labelled nodes. It seems like you're meant to use the left-right instructions to navigate the network. Perhaps, if you have the camel follow the same instructions, you can escape the haunted wasteland. After examining the maps for a bit, two nodes stick out, AAA and ZZZ. AAA is where you start, and you follow the left-right instructions until you reach ZZZ, which is your destination. This format defines each node of the network individually. So you can see there, we've got this. So we start at AAA, and the first is we go right. So we go to CCC. After CCC, we've got a left instruction, which takes us to ZZZ, which is at the end. So the nodes are on the left, what they're connected to is on the right, and we use the left-right instructions to know which one of those to pick. We got to ZZZ in 2 steps. Of course, you might not find ZZZ right away. If you run out of left-right instructions, you need to repeat the whole sequence of instructions as necessary, so basically they go on infinitely. So for example, here's a situation that takes 6 steps to reach ZZZ. Starting at AAA, we follow the left-right instructions. So let's have a look at this one. So this takes 6 steps. So we start at AAA, we go left to BBB. We then go left again to AAA. We then hit a right instruction, which is BBB. We hit another left instruction, which is AAA. We hit a left instruction again, which is BBB. And the final right instruction goes to ZZZ, which is our destination. So your job, using the text file I've given you, is to work out how many steps it takes to get from AAA to ZZZ. So now that we've read the task, let's have a look at the skills that we need to cover. So we need to cover the basic programming constructs. This is sequence selection and iteration, and we're going to be using all 3 of them. We're going to be looking at file handling techniques, string manipulation, and also dictionaries. It is worth noting that the task was very tough. However, once we break it down, it should hopefully be easy for you to understand. Dictionaries are something that are partially covered in the A level, but not at the GCSE level, but it's a useful skill for us to know, so we'll have a look at that as well. So first off, we need to extract the directions out of our text file, and that's the top line. And this is a pretty simple thing to do because it's just a string. So we can see there we've got directions equals LLR. A string in Python is just an array of characters, and we can cycle through them as such, so we don't actually need to split those values. Once we've got it into a variable, it will work happily for us. So the next bit is a dictionary. Now dictionaries are quite difficult. So a dictionary is a data structure that holds key value pairs. This means that there is an identifier, a key, and then a value that goes with it. Much like in a physical dictionary, you have a word, which is the key, and the definition of that word, which would be the value. Here is a real life example of that. So I've started creating a dictionary in Python of different kinds of fruit. So you can see I've called it dictionary, and then we've got the curly brackets. So in Python, these curly brackets denote that we're using a dictionary. Our key value pairs are then in there, separated by colons. So you can see there I've got apple, which is the key, and the value is the round fruit of a tree of the rose family, which typically has thin green, red skin and crisp flesh. We then also have a banana there as well. So this example is like a physical dictionary. The key is the word and the value is the definition that we are looking up. Here's another example of a dictionary using the task data that was in the example. You can see I've called this network. On the left I've got the nodes, and on the right I have got the values shown as a list, and they're the destinations from there as well, and the colon splits them up. It's worth knowing that the value can be anything. It could be an integer, a list, a string, a float. It could be anything at all. So this is the example given in the problem, and we can use it to test our program. I've called it dictionary, I've called the dictionary network. However, you can name it map or anything else that you like. But remember, when we're looking at program maintainability, you're best to make sure that it is connected to what you're actually doing. The next job is to read the file. Now the file is pretty easy to read in. We can do this in 3 lines. The first line opens up the text file in read mode and assigns it to a value called file. We then create a variable called data, and we use file.readlines to read all that data in, and it puts it in as a list with the identifier data, and we then close that file. The reason why we read everything in as a list is that we can then process each line individually of each other, and it can be fully independent. Now, string manipulation is pretty difficult and it can be quite hard, especially with the fact that each language implements it differently. So now that we have each line, we can extract the information that we need, and for the network, each line is laid out the same, so we can use string manipulation to slice our strings into the parts that we actually need. And string slicing allows us to extract data while getting rid of the rest. Here's an example using the string computer science. You can see I've got three print statements underneath that goes there. And in the square brackets, a bit like if you were referencing a list, we put indexes of values. Now, it's laid out a little bit differently because we have this colon. If we didn't have the colon, it would give us a single character back. Okay? With the colon, it allows us to slice certain parts of the string. The value on the left is the index that you start at. So in the top line, you can see we don't have a value on the left of the colon. So that means start at the beginning. The next one says 9, which is S. So that's the index of 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. The value on the right then gives us the value that we're going up to, but not including. So the first one, you can see it goes up to 8. So that would be 0, 1, 2, 3, 4, 5, 6, 7, 8 is the space. So it doesn't include that index, it just goes up to it. So that gives us computer. Same way on the second line, we've got 9 to 12. So 9, 10, 11, 12. It ignores index 12 and just takes SCI. And because it's omitted in the final one, that takes us to the end of the string, which gives us science. So, now that we've got the theory of this behind us, let's actually go and create the program. So now that we've read the task and we've gone over all the theory, let's actually create the program. So, just because I'm quickly programming in here, I'm just going to use the Raspberry Pi editor. I've already put my text file in and it's called Haunted Wasteland. So, first thing that we need to do is to actually gather the information from the file. So we can do that by doing file equals open. So this is just like the PowerPoint. Haunted Wasteland.txt, comma R. Then we can do data equals file.readlines. Finally, file.close. So this reads our file in. Readlines goes through the entire file and puts each line into a list for us, and we've called that data, and then we've closed it. So the next thing that we need to do is to set up our variables. Okay, so I'm going to have a program counter, and that's going to give me that's going to tell me where in the directions we currently are. I'm going to have a value called current, and that's going to keep track of what node I'm currently on. Now, because I haven't started yet, the current is going to be AAA, which is the start. We are then going to create a variable called steps, and that's going to keep track of our answer. I'm going to have network, which is going to be our empty dictionary. So I'm starting with it empty because I'm reading in from the file, and I'm going to update that as I go. And finally, we want to get our directions. So the directions are pretty easy to get because they're already in that array that we've built earlier. So that's going to be at data 0. So that gives us the top line. What we are going to need to do is we're going to have to add on this value here, which is .strip. And what that means is, and I'm going to use line 3 as the example here. At the end of every line of our text file, there is a secret character that tells a text file that we've gone to the next line, and we can't see that. Okay, it's a non-printable character. So what .strip does, it gets rid of that, so then we don't have an extra character on the end. Because otherwise we'll try processing something that doesn't actually exist. So .strip gets rid of that for us. Now it's time to actually build our network. And we're going to do this pretty easily. So the first thing we're going to do is we're going to say for index in range, we're going to go from index 2 to the length of data. Now the reason why we're starting at index 2 is pretty simple. Index 0, or line 1, we've already extracted. Line 2, index 1, is empty, so we don't want that. Line 3, or index 2, starts the data that we actually want, and if we follow that all the way to the end of the file, it's the last value. So that's exactly what we need. So we're going to go from index 2 to the end. So to build it up, we're going to grab a key, and to do that, I'm going to say data at index, so that keeps track of the line that we're on. And then we're going to use another set of square brackets to slice the string of what we need. And I want those first 3 characters. So I'm going to put :3. So remember, that gets me indexes 0, 1 and 2. Okay, it goes up to index 3 but doesn't include. So 0, 1, 2 gives me PGQ. Okay. We then want the value, and to do that we're going to do the same of data index, and this time we're going to go from index 7 up to index 15. So that's 0, 1, 2, 3, 4, 5, 6, 7 starts me at the Q. 15 is the end bracket. Now remember, it only goes up to that value, it doesn't actually include it. So it only is going to give us QRB to MJB, which is perfect. However, we also need to split that into a list. So what's really helpful for us is at the end of that line we can do .split, and we can put in the comma and the space, and that shows how that split happens. We then put that into our array by doing network and then key in square brackets equals value, and that adds it into our network, and we can test that by doing print network, and if I press run, that should hopefully give me some confusing code, but it shows me the entire network that I have, and you can see that I've completely extracted that first line correctly. There's no equals, there's no round brackets, there's no commas that are within the value. It's extracted perfectly. So the next stage, and I'm just going to clear that just so it makes it a bit easier. The next stage is to actually run the network. And to do that, I'm going to make a conditional loop and say while current does not equal ZZZ. So this is a condition. We know the end is at ZZZ and we are not there yet because we're currently at A. So by using that loop, that is perfect for what we actually need. The next thing is to work out if we're going left or right. So I'm going to say if directions square brackets and then put PC, which is our program counter, equals L. So on the first lap round, it's going to start at the first character. So that's good for us, and we can update our program counter as we go along. And what I'm going to do is I'm going to say current equals network.get, and I'm going to say current. So that gives me the entire value, which is that list. However, I only want one element from there. So I'm then going to use a square bracket and extract the left element, which would be at index 0. To find the right value, whoops, just a bit of a formatting error there. We're going to do roughly the same thing. I'm going to say current equals network.get current, and this time I'm going to go with 1. So that gets the correct side either way. The next job is to increase the program counter. Now what some people do is they will say program counter equals program counter plus 1, which is brilliant. That does increase it by 1. However, as we said in the task, when you get to the end it might need to repeat. So to loop it back round, what we can do at the end is we can say mod by the length of directions. So that loops it round back to the beginning. You could also just use an if statement and say if PC is greater than or equal to the length of directions, PC equals 0. And that would also work. We then need to increase steps by 1 because that's keeping track of our answer. The final thing to do outside of our loop is to print the answer. So I'm going to say print steps. And if I click run now, I should get the answer, which is 13,019.